right. Welcome to this webinar, Mikkel. Nice to see you again.
Hello, Rosbir.
Hey, how are you
Good
doing?
morning.
Good morning.
Fine.
Doing good?
Yeah, I'm good. I'm good.
So today in this
Hmm?
webinar, I invite you and we're going to talk about motion control using ctrlX Core.
Hmm.
And just to
Yeah.
introduce you a little bit, that I've been working on ctrlX Core. I think last year I made a lot of videos. I don't know if you have seen it, but I was quite
Yep.
curious to see how we can use it with Simumatik. So here we are today.
Yeah. Yeah, and you are the expert.
Oh,
So
no, I'm not.
today you are talking, and I'm gonna be asking questions. And
Okay.
yeah, yeah,
Yes,
good.
thanks to Daniel, our colleague, who made this beautiful system. This is like Pick and Place Gantry, which we're going to talk about today.
Mm-hmm.
And I will show you more in detail in the Simumatik, but just to introduce you, this is having linear and rotary motion. And we are going to control that using ctrlX Core. So
Yeah.
first I will introduce you the system a little bit, and then I will introduce you ctrlX Core. I have a hardware on my back. If you can see on that side, it's not
Mm-hmm.
so big, but it's running on my background. It's live hardware I'm going to connect to Simumatik. And then we will discuss few things about how to do motion control, which library objects I'm using, and basically how I program this whole system.
Yeah, and I will say that this system is it has been published,
Yeah.
and the main goal with this system is for us to experiment with different platforms, how we can do motion control or axis control, but also for our users to experiment by themselves and get familiar with how you integrate Simumatik when you want to do motion. Yeah,
Okay.
because IO signal integration, we have done it a lot,
Okay.
but using axis is something
Yeah,
that a lot of our users ask.
that's
Partly
right.
the goal of this webinar is to say, okay, now we have a system, as you say, Daniel, our colleague did it, and it's like the entry point to start playing with the linear or rotational axis. Yeah.
Okay. One thing I would
Mm.
also like to highlight, when I was creating the program for the system, there were two ways, open loop and closed loop, like we were discussing before. And
Yeah.
here I have used the open loop because it was
Yeah.
hard to configure my feedback from
Yeah.
Simumatik back to ctrlX Core. But
Yeah, we can discuss that now, and we
yeah,
can tell them how is the strategy when you do motion controlling
right.
in the PLC, and what can the model provide. Yeah.
Okay, so let me
Good.
just jump to
Yeah.
the workspace. So
Mhm.
I hope you can see it now. So that's the
Yeah.
system, Pick and Place Gantry, we call it, and it's a public system. If viewers you want to try, you can go to public system, search for Gantry, and you will find this system. So
Mhm.
let me introduce you. What do we have it here? So in the beginning, we have a big panel, and that's basically all the electrical controls are here. So we have emergency stop, some mode, start, stop, reset, enable robot or gantry, and some joystick to move the axis to find, if you want to find specific position or set points, you can do that manually from here. And if
Mhm.
I just hit start emulation, and if I open the panel, you will see we have some PLC, generic PLC. So here is,
Mhm.
this is the Simumatik generic PLC, which we connect with ctrlX Core. Later on, I will show you. And we have
Mhm.
digital input cards, 2 digital input cards, and 1 digital output, and 1 analog input. So I will tell you where do we use that. On the bottom, some
Yeah.
contactors, some induction motors for the conveyor. This is the industrial socket for 3-phase. And on the right side, you will also see another motor. So motors we are using to control the entry conveyor and exit conveyor. So these two induction motors with the contactors. And this is our XYZ gantry. So this gantry is controlled by servo drives. And these servo drives you
Yeah.
don't see in the panel, but they are lying on the back side. Feel free to move it
Mhm.
anywhere you like. This on the bottom.
Mhm.
So we
Yeah.
have 3 linear axes. This is an X, Y, and Z, and 1 rotary axis. Now why rotary? Because if you notice carefully, we have one gripper with 2 gripping action. One on the bottom,
Mhm.
one on the top. So you can move these 2, and you can
Yeah.
select which one you want to use. And to move that, you need a rotary axis. For that, we are using a rotary
Yeah.
axis here.
Mm.
We will talk about why we need 2, what's the use case for that. So
Yeah.
the system is very simple. In the beginning, we have here, if you see this blue dot, this is for emitting the objects. So if I click on reset emulation, select this and open my panels, you can see that it has a product already selected with one item. This is a special dishwasher product, we call it. We're going to emit from here. And once the product is emitted, we have a digital sensor, basically photoelectric, to tell the PLC product is available. And when this happens, the product will start running on the conveyor, some guides to align the product, and finally we have another sensor to say product is ready to pick. So when product is ready to pick, we are going to guide our system to pick it up using some motion and place in the washer. And then the washer is also having inbuilt washing mechanism. So we close the door, we start washing it. So it has a light which will tell you that it's washing. And we have a washing time, which can be selected from here. By default is 10 seconds. And after the washing, this will pick it up and place it on the other conveyor. And this will take the product to the end where we have an exit, which will take the product out of here. So very simple, nothing too much complication. And that's our system. Do you have any questions?
Yeah, so all the wiring is already done.
Yes.
Signals to control the motor contactors, the washing machine, everything is already wired to the iOS.
This I can show
but
you.
we have, sure.
So for example, we have this sensor. If you click on the sensor, you can see where it is connected. So you can take your mouse here, it will say PLC in IN03. Now if you see the path, it says electric cabinet 02 PLC in. So you can see electrical cabinet on the left side, and 02 PLC in is this one. That's the PLC digital input card. And on the inputs, you can see different inputs connected. So this was like, first one is the start button, which was on the panel. And then you have enable robot button and reset button. So all the connections are already done. So if you are using it for the first time, PLC connections are done. You just can go here and see what is connected where. I'm not sure if we have done the 2D drawing here already. Maybe it is there. Yeah, it's there.
Yeah.
So here you can also see which input is connected to which part of the PLC.
Yeah. We could actually have as an asset in this system just a copy of the IO mapping, maybe.
This is one way we can connect, make a PDF and show it there. Also, if you want, I can also upload my PLC program. There I also define the IOs, another possibility. So
another question. So if you select this gantry device, which are the inputs and outputs we have in there? Which connections can we?
This gantry is actually controlled by servo drives. So you can see on the right side, we have joint motor gripper to move the motor gripper joint. So basically this XYZ gantry has joint motors and links. So we define this joint motors and link inside this gantry. So if I show you a little bit in the portal, open component page, in the editor, you will see we have several joints and links. So these joint links are explained more in our courses, Component Creator, where I was talking about how to create a robot, and there I explained a little bit about that. But for example, when you move this in X-axis, you have a joint and link for that. So these joint link, if you open this joint, you have a joint motor inside. So in this joint motor, we have to give a value. So this value comes from the servo drive. That's how they are connected. And here,
but the servo drive is outside this component. So
yes,
this
it's
component
outside the component.
is the mechatronics, we will say, of the gantry, but the servo drive is outside.
This I will show you shortly. And here you can also define the mode if you want in position mode or velocity mode. So at the moment we are working on position mode. And you can also get the feedback, which I'm not using at the moment, but you can also get a feedback from this device. So this is, similarly, we have more axes. This is for X-axis, Y-axis, Z-axis, and this is the rotational axis. And then you have some pressure input. Why we need a pressure? Because we have a gripper, and gripper needs a pneumatic action to close and open. So that's why we give a pneumatic supply as an input. And then you have a feedback from the gripper. If the gripper sensor is up or down, which means which gripper is at the moment is active, you can get the feedback as well. And you can also get the feedback if gripper is closed or if gripper is open.
Cool.
So two feedbacks. And now coming to the servo drives, which I can show you lying on the floor. For sure, you can put it in the panel. So if I go a little bit inside, so that's my linear drive X, Y, Z. Actually, they are on the top of each other, so all the drives are in the same position. I select on the X, and on the right side, you can see position as the mode is position mode. And actual position variable. This is actually reading from my gantry as a feedback to show what's the actual position. And then you can define the variables where you can read this position. We are not reading at the moment.
Yeah, for that you need to connect an input to the drive, right? The first port.
Yeah, the first port here. We need to drive.
Yeah.
Access relation, I just asked you today in the morning what is access relation is actually, it's a gain factor, which you can get as a feedback from the drive. And the driver type, very important, is OPC UA client at the moment. So what I'm doing actually, I'm connected to this servo drive via OPC UA. So my controller, which is ctrlX core, has an OPC UA server inside. So this drive will connect as an OPC UA client. And then it can share the information via OPC UA about the access.
And in this case, this will read the set point.
Yes.
And if we would like, it could feedback with the actual position.
So at the moment, feedback variable is none, so I'm not using it. But the set point variable, you can see it here. And this is the path of my OPC UA tag inside. So I will show you shortly. This is global variable, r-axis x, that is giving me the value of x-axis in real time. And then very important part is the setup parameters. So while connecting to ctrlX core, I need to enter my username and password, so which was by default Bosch Rexroth. So that's what you see here. And then the IP address of my ctrlX core and the port address of OPC UA. So that's the endpoint address, and RPI is the time, how much time it takes to share the information. It's 50 seconds, milliseconds by default.
How often?
How often it connects. So
and this is just in your application. If someone wants to do the same but with another kind of controller, using any other driver, you just change that to the setup and select. You select which is the variable you want to read the set point from, and in case you would like to feedback with the actual position, you can select that as well.
Exactly.
Maybe we can discuss now about the open closed loop thing now when we are talking about this.
Right.
Yeah, because not all the controllers actually allowed when you are working with virtual axis like we will do here, because even if you have the real PLC behind you, you don't have the real servo controllers.
Right.
So you kind of virtualize the axis.
Right.
And different manufacturers have different approaches. They kind of idealize this servo or this axis. So when you call a move absolute or move relative function, they will generate an ideal path.
Right.
And basically the set point and the actual position in the controller will be the same.
Right.
With pretty much no delay. And in those cases, we cannot do much because it's a limitation in the PLC controller. So even if we would like to emulate the encoder, like you were mentioning before, with the actual position, we wouldn't be able to write that value in the
That was the
in the controller.
I also had.
Yeah. Some platforms they allow. For example, we have experience with TwinCAT. You can virtualize or select the drives to run in simulated mode, but you can decide to have a encoder value coming from the outside somewhere, and that outside can be Simumatik. So somehow Simumatik gets the set point. We move the joint in a specific device or component, and we can read the actual position, which will be somehow delayed with the set point, because we know the physics takes some time, and that value will come to the PLC.
That's what I
through the driver.
I also took a delay, but I will show you that later as well. But if I click on my portal, you can see my joint maximum speed is 0.4, so 40%. So what is happening, the speed in my motion is 1 meter per second, but here it's 0.4 meter per second because it has to catch up the set point with a delay. Otherwise, we have a little bit jerky motion.
Yeah.
So this is the
Yeah.
limitation, but we could solve it with changing the speed.
Yeah.
So now I would like to introduce you a little bit about ctrlX core. So maybe I can switch back to the other slide. And so here I'm using ctrlX core, a hardware device. You can call this device an edge device or PLC or HMI or OPC server device. You can call it anything based on what apps are installed inside. So they basically work in a similar way how mobile phone work. So you have an app store and you install the apps, and then you can use your mobile phone for that app usage, right? In this case as well, if I want to use this ctrlX core just as an HMI device, I can install an HMI apps, and in their app store there are many apps available. So in this,
it's just a computer or like
it's
all-in-one.
working on the base of Linux environment.
Okay.
So if I show you here, switch back to my workspace. I have my IP address of this device, and I am inside the device right now. So this interface, you can see it here. And here you can see I have several apps installed. This I can maybe show you from settings and apps. And then you will see here we have some apps installed. One is Node-RED. This is the core app, OPC server, PLC, and Motion. So in this example, I needed to use this device as a PLC and as an OPC server, and I also need some motion for the access. So that's why I installed these 3 apps. If you want to use it for different purpose, you can add or just replace all the apps as well. And
is there any limitation? Sorry, Rasmus.
Yeah,
is there any limitation? How many apps you can install? Do they have different hardware versions, more memory, less memory?
They have different versions. Mine one is getting a little bit old now, but the newer version for sure has more space and more higher computer processing power. But still, it works great. The version I have, I think, is the one version older. But the limitation is just the memory card. You can insert the memory card, and then you can have more space for your app installations.
Okay.
This is possible.
Is it rack? Is it a rack PC? You can put it on a rack, or
you can connect further modules with the Ethernet port. Let me go back to the slide. You have these ports here, which you can use to connect to further modules. For sure, it also has a rack. Mine one has a rack. The photo here, I'm not sure if this one has a rack.
Yeah, it looks like a rack. Yeah.
I have a rack, and it has been connected with Ethernet module and digital IOs, so you can connect further modules next to it. That is possible.
Yeah. And they do standard Ethernet based
more Ethernet
field buses, like you can do Profinet or Ethernet IP.
Yeah,
you can do all those.
You can do all those, but specifically I use EtherCAT for reading from my IOs. I have an EtherCAT hardware module connected to it. But for sure, you have flexibility to connect to different protocols when you have these Ethernet ports available.
Nice. Yeah.
Okay, so let's go back here. And yeah, like I said, we have several apps installed inside. And the main app which I'm using here is the Motion app. And in the Motion app, I have defined some axes. So I was moving it, and this was showing some error. So I have one rotational axis. This is for my gripper to rotate. Okay, and X, Y, Z axis is for the gantry, right? And once you define the axis, you can also go on this icon here, and you can define the limits of these axes. So for example, here I have defined the position limit is this is right now in radians. This is for rotational axis, 0 and 3.14. And this velocity, let me see the units again. It's also in radians per second. So here you can define the units, and then you can define the limits. And then you can also define limits for acceleration, deceleration, and jerk. So this is same for all the axes. You can define the limits here as well for x-axis. In the x-axis, I'm using meter per second because in Simumatik, we have by default meter per second as a speed and as a unit of length meters. And there I define the limits. So once you define the limits, your axis will not go beyond these limits. That's why I need to define it.
And then that brings us to the previous question, what would happen
Mhm.
if you set those limits wrongly, but you run everything in open loop, like we will do now? You could command this
That's
axis
true.
to a position or rotation
True.
that physically is not possible,
Right.
but your program wouldn't say anything. But if you can limit this motion in the model and get the feedback from the encoder, from the model,
That's right.
actually we could trigger an axis movement error
That's true.
telling, okay, set point says 1.2 meters, but the
Right.
encoder is stopping
At
0.8.
Mhm.
Yeah, whatever.
We will not get the
It's
feedback right now, but if we have
yeah,
a close loop, we
yeah,
can
yeah,
get the feedback.
yeah.
That's right.
That so it's something that it can be done. Maybe we can experiment a little bit more with ctrlX.
Yeah.
We can talk to the engineers. It will be nice if we can explore a little
That's
bit
true.
more and see if we can close the
Close
loops
the loop.
at certain time somehow.
That's right.
Yeah.
We
One
can-
question:
Mhm.
What do you have in the commissioning tab?
Yeah, I was about to come to that.
Okay,
So
cool.
let me just split the window. That would be easier for me to show. So I'll bring the Simumatik out.
Mhm.
And let me reset my errors. And I start. So once I start my system, because my system is already connected, and right
Mhm.
now you can see that the state is disabled, right? And if I
Mhm.
go to commissioning as well, you will see that the power is not on. Once I
Mhm.
click this button, this will trigger the power of my drives. And now in the commissioning, I can move my axis. So for example, right now
Oh.
you can see I am showing you my gripper, and that's
Ah, it's
my
rotation.
showing in radians. So if I click on plus, it should move the gripper.
Yeah,
So you can
cool.
commission your Simumatik model using this commission tab in axis. Similarly, we can also do it for XYZ axis. So if the screen is a bit small, let me open my X. Sorry. I have to zoom out a little bit.
Oh no, yeah.
So here I can also move my portal in XYZ axis based on, this is basically just jogging. So you can see now it's moving. Yeah, but it's moving in steps because the speed is way too less.
Yeah,
It's
it's
0.1.
very slow, yeah.
It's 0.1.
Yeah.
But you can imagine in commissioning, if you have
Yep.
maybe a real XYZ portal or a virtual portal, you can move it from here just to realize the positions.
What happens if you use the joysticks like you showed me
The
before?
joystick, yeah, this you can also use.
Will it change here? Will it change
Yes,
the
it will
value?
change
Will
here
it be
as well.
updated here?
The joystick I have on my panel, I can show you now. Because the joystick is actually sending the value to my PLC, and PLC has some function block inside for jog. I will show you that as well.
Yeah.
And once the value changes there, it should also reflect here. Let me close this one for a while and zoom out a little bit.
Now we see it.
Positions. Let me see if I can show that as well. So I will try to move the robot left, and now you can see the position. You can also see the velocity here for the X. And also for the Z axis, I can show you. This is for the Z axis. You should be.
Maybe it's already up, or?
Oh, maybe it's already maximum up. Yeah, that's right. And now it's going down. Right.
Okay.
And you can see also discrete motion. So both ways you can see the values in the commissioning. What is the current state of your axis?
Cool.
And what you can also do is, besides the jog, you can also go for positioning, and then you can write where you want the set point, and then it will just move to that set point. Another way to commission.
Yeah.
This is also possible.
Quite good interface.
Yeah, it's a very easy to set up as well, these axes XYZ. And now if I show you one more part, which I'm not using in this video, but it's just interesting to know, they have inbuilt kinematics. So here you can also add the kinematics, and the benefit is they have inbuilt motion control. So we don't need to use the PLC program for that. You can just give the commands via Python script or JavaScript, and then just put the set point, it will move accordingly using the inbuilt kinematics. Right now we are doing everything using the PLC program, but you can also
standard blocks,
standard functional library, which is provided by ctrlX Core as well. So that's just a little bit about ctrlX Core. Now I would like to show you how my PLC program is talking to this Pick and Place Gantry. So like I mentioned before, in this Pick and Place Gantry, we have a PLC here. So this PLC we need for the digital signals. We have several sensors on the conveyor, and we have sensors on our portal, and we have buttons here. So for that, we need a PLC for digital signals. And then we have these drives, servo drives. One more time, I want to show you drives, which are sending the value of, or reading the value of access. So we have some communication going on. So in this case, in my PLC program, I will show you first my controller. Here you can see that it's ctrlX Core with the IP address 192.168.0.76, and for sure you need some device description to install first, and then you can find this controller. And this software kind of looked like codices, but the software is called ctrlX PLC Engineering. This is actually based on codices, you can see on the bottom. Look and feel like codices. So if you are a codices programmer, you can right away use this software. It's super easy to use. So I have my...
sorry, Rashbir, the connection in the generic PLC is also OPC UA, right?
Yes,
you just
it's OPC
you use the same channel, same channel for drives and the iOS. Good.
So the connection here, I'm also using generic PLC acting as an OPC UA client. So here the main part is the global library. I mean just global variable, sorry. So here what do I have mentioned? I have mentioned X, Y, Z and RZ axis. That's my rotation axis, and X, Y, Z, 3 variables, and they are reading this X axis, Y axis and Z axis. And these are the names that I defined in my ctrlX Core. So they are connected to ctrlX Core like this. And one more part I forgot to mention, in ctrlX Core, we also have an OPC UA server running. So it has an OPC UA server. It's also by an app. I installed the app and server was there. And this OPC UA server has an endpoint address, which I give in Simumatik. So when I connect my global variable, this is connected by OPC UA.
And did you add those 4 variables manually, or did they appear when you...
No, I added manually. This
was manually.
This was mentioned in one of their documentation. And then I have 4 variables. These are X, Y, Z, R, Z. These are just the real values, the variable values which I'm reading from this axis as well, from this X, Y, Z.
Okay, so this is the actual position, the virtual axis position.
And these actual positions are in the end going to my portal. So if you see my portal again, and I show you the drive, let's say X drive, you can see I have mentioned the set point variable. This is global variable R axis X. So that's the part of my OPC UA. And this R axis X is actually coming from here. So here I'm getting...
This is what you are reading. You are reading like set point, but it's actually the actual position, because we're running an open loop.
Exactly. And then I have similarly for YZ and RZ, and then PLC IOs. These are for my PLC digital input card. This is Simumatik input 1, because if I go here and I show you my PLC in electrical cabinet, PLC input, I have this variable defined here, Simumatik inputs 1. So similarly, this PLC engineering app or PLC engineering software also communicating to Simumatik, and that's the variable. Similarly, variable for second card and outputs and dishwasher. Now I took a separate variable for dishwasher because I was getting the feedback from dishwasher as an analog input. This tells you what's the status of dishwasher. Is it still washing, or it has washed completely, or is it not started yet? So this was coming as an analog input. That's why I took it extra here.
Do you need to use the symbol configuration or not?
Yes, here I have to use symbol configuration. And in the symbol configuration, I add all the global variables. And that's how I got connected to OPC UA server.
One thing, I realized you have used the direct addressing in Simumatik. maybe we can
In
tell about that
Simumatik?
instead of just writing air axis X, you write a node
Oh yeah.
number in the OPC
You
server.
mean this one?
Yeah,
Okay,
this
so
is
I tell you
this
why.
is a quicker way. Yeah, this is a
Yeah.
quicker way. Can you tell a little
Yeah.
bit? Yeah.
So while working on this project, first I just used Simumatik input like this,
Yep.
which did work, but it took
Mm.
a lot of time for both the platform to communicate with each other. I believe this was because the tag was inside several folders, and it
Yeah.
took time to look for this tag and then simulate the values. So if you do it like this, and the question is, how do I get this path? The easiest way was I used UExpert, and you connect to UExpert with the ctrlX core, and then you can browse the tag, and there you can find the path. I just copy that path and paste it here. And now the connection is much faster because it's directly accessing this address in this path.
Yeah.
So this is much faster. So if
Yeah.
you face some latency problem, use this direct path. This would I would highly
Yeah,
suggest.
more than latency, the issue with OPC UA is that if you just write the name of the variable, the client needs to crawl the entire server
Exactly.
until it finds. So it's just in the beginning. It may take a lot of time to find the variable. Once the variable is found, the latency is going to be the same. But it may take, in your case, it won't take time. It's going to be just some milliseconds because it already knows the address of the variable now, complete
so it's
address.
Just in the beginning, yeah.
Yeah, it's just the beginning. I think that's why you were seeing this delay of 10 seconds or whatever, because you had thousands of variables and you need to crawl them one by one. Yeah.
It actually got worse than 10 seconds when I add all the drives. In the beginning, just with one drive, it was 10 seconds, and then it got minutes as well. So this really
that's
helped.
That's why I asked you about the symbol configuration, because I wondered if you could check out most of the memory, but you actually have, because you just have checked the global.
Yeah, just the global variables.
But it happens anyway in some platforms, and it looks like in this implementation of the OPC UA server by ctrlX, they probably introduce in the OPC UA server automatically a lot of variables related to motion. Yeah, and that is something that maybe you cannot change, which makes crawling very slow.
That's right.
Compared to maybe other platforms where you can select exactly which are the variables you want to have in the OPC UA server. Yeah.
One thing I would like to highlight here, that in ctrlX core they have a data layer. In this data layer, you have all the information that you want to access internally or externally. So this PLC variable which I was showing you is inside this PLC folder, and then you go inside the app, and then the application, and I think in the system, and then global variable, and then here you find all the access. So you can also find it here. So it has to, for sure, go inside, and finally find this variables.
Yeah.
So this is by default here. And here you can also get the information about the access profile, and different state of your access. You can also find it here.
Yeah.
So, okay, coming back to this one. So the communication is via OPC UA for the PLC and for the drives.
Yeah.
And now what I do is I will just try to see if
you were showing
the PLC program,
actually. I'm asking a lot of questions, but you were going through the PLC program.
Oh yeah, sorry, yeah, we were at the PLC program. Okay, so I will first like to show you the global variable. This we just talked about. We have defined the variables, and we go to now PLC program. So in the PLC program, I have define two function blocks. For sure, there are different ways to write the PLC program. Mine way was that I defined one function block for control sequence and one function block for the motion. So these two instances are defined here. So let's see what is in the motion first. So inside the motion program, you can see we have several function blocks. For example, MC reset. This is for x-axis. So with this MC reset, you can reset your drive. If your drive has some error, you can reset that with this MC reset block. So to execute that, I have a panel reset and I have a web reset. And what this is going to reset is x-axis, which is defining global variable. So panel reset is basically the button which you can find here. So here
The
we
physical,
the physical button. This white button is the reset. This I use to reset my drives. And web reset is I made a small visualization screen. So here I have reset access button. This can also reset my drive. So both ways it is possible. And similarly, we have it for Y and Z. So here you can see that the axis names are changed. And then RZ, that's the rotational axis. So 4 blocks for reset. And then we have similarly 4 blocks for powering the drives. So these blocks, in a way, you can find it in the library manager, because once you write this motion program, you need a library. And the library is called CXA, PLC Open. And I use this library. Inside this, you can find several commands which are ready to use. These are function blocks. You can just call it. And here you can see that I have been using reset and enable. So these 2 blocks I was using.
I will say those are pretty standard. I don't know if they are in the IEC, part of the IEC standard, but the MC blocks for motion are kind of
quite
standard, right?
Yeah, I think so. I think it's the kind of similar when we use virtual axis and codices. That's also MC block, I think so. So power for X, Y, and Z, and for RZ, and then comes the actual position. This is the actual position block, which is going to read the actual position from my axis here, which we were watching before. So if we go to commissioning, these actual positions I'm getting from this block. And here you just need to define the axis which you want to read. And this is like enable, panel enable, and web enable button. So this panel enable again is this green button which will enable that and start reading it. Web enable is in the visualization, this power button. So X, Y, Z, and RZ, and then comes the jog. In the jog, the thing which I was showing you in the beginning, how to move using these joysticks, this is done by the jog command. So these joysticks are actually sending signal to PLC for the forward, reverse, and this will jog forward and reverse. And then you can define the velocity, acceleration, deceleration, and jerk. And these parameters I am actually defining in my visualization. So if I now go online, you can see the values are here for jog. And that's the real-time positioning of my axis. And similarly for y-axis, z-axis, and rotational axis. And then comes finally the positioning. So I'm using move absolute command to give set points in absolute mode. And here comes the position where I want to move it. And this position comes once you calibrate your gantry and you know where the robot has to go or the gantry has to go to pick the position. You can first do by jog and find out the position, note it down, and then you can just write this position here and it will move to that position. And you can define
you can also save some recipes for different positions and so on, X, Y, Z, R, Z, and then in your sequence you will just select, okay, go here, you put you write the values and the axis will move.
So you can define some variables or arrays for pick position, place position, washing position, and so on. So I have it for move absolute X, Y, and Z, and RZ. So RZ actually I'm not using. I'm always in the 0 degree. So if you want, you can also move the robot. We will talk about that once we are moving the gantry. So that's it. That's the motion block. Super easy. Just drag and drop the function block, write down your tags, and define the axis. Nothing too much.
And the trick to move the model in Simumatik is just using this read actual position, moving it to the global variable. So the servo component in Simumatik will read those global variables.
Exactly.
As you were saying before.
So this is what we are getting. So if you see the block here, real actual position, this is the actual position coming here. This tag is what I'm connecting to Simumatik. GVL R axis for X, Y, and Z. And this you can also relate for X, Y, Z. Okay, so this was about the motion. And then comes my control function block. My control function block has the sequence. So what is the step 1, step 2, step 3, 4, 5, 6, and so on. So
Yeah.
here in the top, I have some error handling. If I have some errors, then my system will not be initialized, otherwise it's initialized. Then I have a conveyor logic, which means if the sensor comes in the beginning, the sensor is true, it will start the conveyor. And if the object is here, it will stop the conveyor. Super easy. And then conveyor logic for the exit conveyor, and some timer logic, which is basically if the product exit from here after 5 seconds, the conveyor will be off, just so that conveyor is not running all the time. And then some start stop for e-stop, stop and run command, basically nothing, just a variable run is true and false.
Yeah.
Then comes the gantry step. So when the gantry is initialized, if there is no error, we move to step number 1. It's basically when it's running. And step number 1 is the home position. And here I am moving the value 0.0 for X, Y, Z, and RZ. So if you see this axis pose, 0, 1, 2, 3 is basically an array. And this I have defined maybe somewhere on the top. So here I have axis position and axis move. So this is my X, Y, Z, and RZ. And these are the values of position. So the first step is the home position. And when the home position is done, I take some delay, and then just a delay of 0.25 seconds or 0.5 seconds. And then I jump to next step. Then it waits for the product. The conveyor sensor will tell you the product is there. Then it will go to the pick position offset. Pick position offset is not at the product, but on the top. So it will go on the top, and then it will go down, grip the object, then again go to the offset, then go to. So I'll show you right now in the live how it is working. So just several steps, and after last step, it will repeat. So
do you like programming? Do you prefer programming this kind of state machines in structured text rather than using a graph set or a...
Yeah, I have more experience with structure text. I was doing a lot in PLC programming in Siemens, and there we have, I don't know, more than 50, 60 steps. So I'm quite used to a program like this, but for sure you can also use graph. But I
like it. I prefer as well.
Because I like this one more because I find more flexibility. With graph, I don't have much experience. I think it's quite easier in this one because I can call the function block, call the instance directly inside my step in graph. Maybe it's possible, but I don't know how. It takes some time.
Yeah, it's more powerful just directly here. If you want to use the graph, you need to know other tricks, so you can call functions. You can have entry code, exit code in each step, and so on. But it's more visual. The other one,
that's true.
This is more difficult to debug, I would
That's
say.
That's true. I can also imagine.
But it's well structured, so it shouldn't be a problem. It looks very,
and I think
very clear.
In some controllers, there is no graph language, but they have structured text. So still, you are having a win-win situation. So after this control function block, I just have my PLC program, and I just share the information between the motion instance and the control instance. So here you can see some variable coming from control instance to motion to move. So the control instance is telling the motion block when to move and which axis or which position to move. Just these two information. And motion block is telling the control instance that if there is any error or the status of the axis, or if it has finished moving, so done command. That's it. Rest, they are just talking to Simumatik digital inputs and giving the outputs. So,
cool.
So this program, if somebody wants, I can also link it in the webinar description somewhere. They can have a look. All right, so now is the show time. So let's come back here. Now, would you prefer to split the screen and show it together? Be much better?
Yeah, I think if you can split the code.
Yeah, I can split it.
I mean, it's not very easy to follow, but we can see some variables changing and so on.
That's true. I can maybe hide this one here. Maybe here you can, I can zoom out a little bit. So maybe some actual positions of X.
Yeah, exactly.
Okay. So let me see if I have some error in the meanwhile. Okay. So my step 1 is I enable the drives, but drives are already enabled. I reset my drives and reset all the steps, and I click on start. Now I should be ready to go. You can see that everything is at 0, 0 axis. This is the home position. And now only thing I have to do is bring the first product. Rest the sequence will be loop automatically. So to
Okay.
drop the product, I can go to the panel on the bottom and I can say, okay, let me just make it a little bit bigger. Product entry, and I say drop product. Now our product is dropped. It has started to move on the conveyor, and now coming the gantry, you can see that the pick location is changed. So this is picking the object and following the set points and placing it in the washer. And once it is placed, you can see that the washer is on, it's a green light, and there is a light inside, which is kind of like simulating that it's washing. And the washing time is 10 seconds. It will take 10 seconds, and then it's complete. The washer is off. You can see red light. It will pick the object and place it here. You can see that the pick place locations are changed. And the sensor will tell object is here, and this will say I place. It will start the conveyor, and now the next product will come. So very simple sequence for pick and place and washing the product. And now if you see here, another possibility which we were discussing, like once this product is inside it, this gantry has to wait. So to use this waiting time, we can use another gripper to grip another product which could come here. In this case, we just need to move it by 90 degree and pick the product, and then it will pick the washed product, put the unwashed product back, and so that it will save some time. So kind of like
it will save it will save on half a cycle or something like that.
Exactly. So this is why we have two grippers. That's what we were discussing with Daniel when he did that. So I think it's a quite interesting application for playing around with the motion, because you have 3 linear axes, 1 rotary axis, and a lot of digital signals to program a sequence. And if you remember, I was talking about analog input for the washer. I can show you that. I use this washing here. You can see the number is increasing. So this is showing the status of the washing. So when it is 1000,
the time,
it will open the lid, and then so it's telling me what is the status of washing, how much percentage it is done, or how much value. So you can relate the 1000 is basically 100% of the washing sequence, and then it will execute to the next step.
And if someone wants to experiment, instead of dropping the products when the previous one is placed in the exit conveyor, they can have a timer or whatever. They can drop it automatically and so on, and stress a little bit the system.
And I think you can also have a different products here. So based on the product type, you can change the washing time. So maybe one product need more washing, one product need less washing. So you can make different recipes as well. And another important part is when I share this project, this code assist project, if you don't have ctrlX Core, you can use ctrlX Core virtual as well. So in this case, you don't need a hardware. You have a soft PLC or soft ctrlX Core. You can still execute this program. And you can also execute the same code if you just connect with code assist. In code assist, you have soft motion possibility to have a virtual access. And I think the programming would be same. You just need to maybe change some access name and how you declare the access. And rest, you can use the same sequence and play around with the system.
If you want to run the ctrlX completely software, is it you need a virtual machine, or
you can install it in your Windows PC as well? I mean,
it's just a software, and it includes the web
interface is completely same. Apps interface is completely same. It's just you don't have a hardware. It's just a soft PLC. It's just like Codisys soft PLC as well. I shared it with Daniel. I think he would be playing around with that, and maybe he can also execute it.
Very interesting, Rashid.
Yeah,
I think
it was fun programming it as well.
Yeah.
I think I didn't work too much on the motion control, but this was fun to play around.
I mean, it doesn't need to be complicated. I think this approach is what you want. You want to be easy to set up your axis. You want to be using standard functions to do simple movements, and in this case, move absolute is perfect. it doesn't need to be more complicated.
Yeah, I think back in the days when we didn't have this motion object or technology block, we were using PID ourselves to see if the set
Yeah,
point is reached or not. And now everything is included. Just give a
yeah,
set
yeah,
point and read the feedback. It's super easy, I would say.
exactly. Yeah, exactly. I would say the only drawback running this virtual commissioning environment is that we are running open loop. And
Yeah,
as we
that's
were
true.
mentioning,
True.
if you do a mistake, you haven't parameterized your
That's
access
true.
properly, the limits or whatever, you may not see some issues.
That's true.
So I think it's good, and I think we need to explore the possibility to close the loop
Yeah.
because we will see that both the model or the PLC configuration could be wrong before going to the real commissioning.
That's true.
So that's I think that's an
That'd be
interesting
key.
improvement.
And Daniel was also showing that he could do the same with the Siemens PLC, and he tried PLC Sim instance for
Yeah,
PLC Sim Advanced. So
yeah,
there is a possibility to do the same what we are doing right now with other PLC manufacturers.
yeah. And that's kind of what we wanted to challenge today, the audience and the users.
Yeah.
We will be very happy to see your implementations.
That's true.
As Rashbir was mentioning, you can do more stuff. You can use the rotational gripper as well,
Yeah.
improve the sequence. But if you want to do it in another platform, Rockwell, TwinCAD,
Omron.
Omron,
Yeah.
yeah,
We can do that.
yeah. We will be very happy to share
And
your videos.
we
yeah.
were also talking about having a course on motion control. Maybe this is the
Yes.
starting point. We can start
Yeah.
with this webinar, and then maybe I can do with codices one video and one with Siemens. So maybe 3 examples or maybe one more, and then people can realize how they can do it with other PLCs.
Yeah.
It's I think it's quite interesting.
Actually, now when we are talking other PLCs, we can mention also that we just deployed a new version of the gateway. It includes a new experimental driver for ACS motion controllers, which is really, really interesting. We need to explore more, but it looks like a very, very powerful platform for actually motion applications, ACS motion.
Yeah.
And the other one is the driver to connect to Omron PLCs using the FINS protocol. In that case, we can connect to any Omron PLC or FINS protocol compatible PLCs, read and write different kind of variables and so on. Pretty quick native protocol. Because as you remember, we have also the Simumatik Studio Simulator API. Yeah. So this was a good complement. So now we can do virtual commissioning in both.
Oh, so we use the same software, Simumatik Studio.
Yeah, but sometimes maybe you want to use the real PLC, or sometimes you want to use the simulator. So we have both options.
Okay. Oh, that's fun.
Yeah.
Maybe we can try this as well.
Yeah, I think we will have it.
Is it a free software, or you have to pay a license for that?
Simumatik Studio, I think you have a trial for 30 days.
Okay, 30 days, right?
So yeah.
Okay.
But it's on our plans to do this tutorial as well. Yeah.
Okay. I think that was a nice webinar. And what do you think about the next webinar?
Yeah, you remember we were mentioning maybe doing something with ROS and robotics.
This would be
so we have
fun.
that. Yeah, I think we don't need to tell much more now, but something with ROS and robotics. Yeah.
Okay.
It's gonna be very interesting.
Fun. Yeah, ROS, I think we didn't touch at all in any of our webinar. We were always talking about PLC.
Yeah,
but ROS will be fun. And maybe one day we can also do with the virtual reality. I know we are still developing some, or is it finished? This virtual reality interface.
It's still in beta, but if we prepare the equipment, maybe we can do a webinar about that.
Because I have Oculus Quest 1, the first one which came into the market. If you have another one, maybe we can jump in together and see what are the possibilities.
We can try. That will be fun.
All right. So that brings us to the end of the webinar. If you are interested, feel free to check out our LinkedIn page. We post updates about our platform. And for sure, for the next webinar information, feel free to check out our LinkedIn. Yeah.
Thank you, Raspberry.
Then
It was a great webinar.
thank you, Mikhail. Thank you for joining.
Yeah.
I hope we see each other soon
Yeah.
in the next webinar.
Yeah. See you
Okay.
soon.
See you
Bye-bye.
soon.
Have a nice
Bye-bye.
day.
Thank you.